Okay, now we're going to talk about case number 2. Case number 2 is when the square root of a squared plus x squared. We do the same thing. Because it has to be a triangle, I'm going to do this. And we're going to be like, oh, okay, this is equal to c. Therefore, this hypotenuse will evaluate it as the hypotenuse, x squared. Okay? Judging on this, we got to know whether a is going to be here, or x is going to be here, or a going to be here, x is going to be here. Now, we talked about these 3 important things: tangent, sine, and secant. Okay, the reason we use this is so that we don't have a square root of any number or the sum of any numbers on the denominator or the numerator of any system. So we're going to have to look for things that uses tangent, because tangent is opposite over adjacent, which means that we're going to use values that are not square root. Okay, so because tangent is over a and it has to equal x over a, adjacent is going to be a, okay, and opposite is going to be x here, x. Okay, so if we look at this triangle, x is here, a is here, and it's going to be a square root of a squared plus x squared. Okay, now this is the triangle for case number 2. Easy. Now if we take into account, we're going to be like tangent opposite of a, or theta, is going to be equal to x over a, and this happens with this triangle, and that is case number 2 basically. So therefore we can say that x is equal to a times tangent of theta. This is very important because later we're going to have to find the derivative of such things in order to do a substitution. Okay then.